We're going to look now at constant velocity with vectors. So it says here, if an object travels with a constant velocity, the motion can be described using. So we've got r is equal to r0 plus vt. Now what is this talking about here? So your r, this is your final position vector, which equals your initial position vector plus vt. Now if you think what vt is, that's your velocity times time, which gives you your displacement. So that's your this is your change in displacement, basically. So r0 is your initial velocity, initial displacement, and vt is your change of displacement. Okay, very common to use r, but also nearly equally common to use s. So you could also, I would maybe write in as well, you could say this is s, final displacement is equal to your s0. That's what I generally like to use, plus vt as well. So we're going to look at how we can use this in this question. So it says a particle is at a point with position vector. So this is your initial, and it moves with a constant velocity of this. Find the particle's position vector after 10 seconds. So I'm going to use this formula up here. I'm going to say for part A, I'm going to say S is equal to S0 plus Vt, and then we're going to fill this in. So we want to find my final velocity, my final position vector. So it's going to be my initial position vector of 7:14 plus my time times my constant velocity, which is 2 minus 1. So if we just do that out, that's just going to be 7:14 plus 20 minus 10. And then if you do that out, what are you going to get? That's going to be 27. 27.4 is meters is what my final thing is going to be. I've used column vectors here. They use column vectors in the question. Even if they had written, like say they had written this as 7i plus 14j, I would have used column vectors in my question because it saves you so much time. But if they do use the i's and the j's, use column vectors by all means in your working out, as I will be doing, but then change it back. Always give your question back in the format in which they ask the question. Just makes it much nicer for them. Okay. Part B says find the time at which it reaches the coordinates of 45 minus 5. We're going to then use this formula again. I'm going to put in what we know. So we know it has to get to 45 minus 5. Its initial position was 7:14. We don't know the time, that's what we're trying to find, but we do know the velocity which it moved at. Okay, right, don't take this down. This is basically a linear equation. You had 5 is equal to, 6 plus 2 times t. What would you do? You would bring that 6 across and subtract. You'd have a minus 1 is equal to 2t, and then you would divide across by your 2. Okay, it's exactly the same idea. So let's have a wee look and see how this works. So here we'll bring the 7 across. So 45 minus 7, and you'll bring your 14 across. So this is in a column vector here. Let's sort that out, that's a mess. So that's going to be 38, and that's going to be minus 19 is equal to t times 2 minus 1. And then we'll look at the i's. So we're looking at the i's just. So 38 is equal to 2t, which means t is equal to 38 divided by 2, t equals 19. Then we'll look at the j's. You'll have minus 19 is equal to minus t, which means t is equal to 19. Okay, first of all, it is worthwhile doing that to show they're consistent. So it shows they're consistent. So it works. We'll not have to write this in. You'll see this later on in an example. Had they not been consistent, what that would mean, you'll see again, you see this later on. If they'd not been consistent, so say I worked out for my i's, t was 19, and for my j's, t was, 22. They're inconsistent. That means you would never actually get to this point, 45 minus 9. But ours would be consistent, so that means your answer is t is equal to 19 seconds. Okay, 2 more examples in this video. Next one says, a body moves with a constant velocity of -1, 1 from a point A. It says at t is equal to 3, it has a position vector of 3, 1. Find the initial position vector of the body, A. Okay, right. Moves with constant velocity. I'm going to write down my formula. S is equal to S0 plus my V t. So let's just fill in what we know. So at time t, time 3 seconds, it has a position vector of 3, 1. So 3, 1. And then that's my S0, that's what we're trying to find. Plus my V times t, so that's 3 times my initial velocity, which is -1, 1. Okay, let's just sort that out. That means 3, 1 minus 3 times -1, 1 is going to be equal to my S of 0. So my S of 0 is going to be equal to, and then if you just do that, that's going to be 3 minus 3, that's going to be 3 plus 3, that's going to be 6, and 1 minus 3 is just going to be, 1 minus 3 is going to be -2. So that's what you've got. Okay, so find the position vector of the body A, of the body at A. There we are. Lovely. Okay, so that means your point A, we'll write that in, because I did this the other day with the glass and messed this up. So it's 6 minus 2. So A is this point. A is a point 6 minus 2. We'll keep that right. We need that for the last part of the question, which I messed up. Okay. Part B says, find the value of t for which the body is directly north of B. Okay, so, and it tells you, sorry, B has this thing. So this is B. So let's just write that down. B is equal to, B equals 2 minus 9 meters. That's where B is. Right, if you're directly north, now this is a wee diagram. Let's just mark that point on. So 2 minus 9, that's your point B. Okay, if you're directly north, that means you're on this line somewhere, but your coordinate value, your x value is 2, your y value you don't know. Okay, but you do know if you're north, you're still, your x value is still 2, so that's what we've got. So we're going to put this in, we'll write down our formula here. So if it's directly north, I'm going to say let point B, and we'll say 2, and we'll call it 2A. Okay, let this point be 2A. We don't know what it is. We're going to work this out. All right, let me get rid of this wee diagram, give myself a wee bit of space. So that means we're firing everything we know into this. Okay, so I've ended up at 2A. My initial position vector was 6 minus 2, that's what we worked out. My time is what we're trying to find, and my initial velocity is -1, 1. So let's go through that again. Let's go through and see, let's work this all out. We're going to just equate the eyes. We're just going to look at the eyes here. So we're looking at the eyes, and for the eyes, you've got 2 equals 6 plus t times -1. So it's a very easy linear equation. So 2 equals 6 plus t times -1, or 6 minus t. That means t is equal to 6 minus 2, which means your t works out to be 4. So 4 seconds then is my answer. Okay, that's not easy. Okay, the last bit, part C, says calculate the distance of A, B. Now let's just write these in again. A was 6 minus 2, and your B was 2 minus 9. So to find the distance between those 2 points, you can just use your formula to do this. I would just say then my distance AB. So this really is from your coordinate formula from way back in GCSE when you were looking at straight lines. You know the points are 2 and -6, 2 minus 6 and 2 minus 9. Do your x difference, which is going to be 6 minus 2 squared. My y difference then is going to be -2 minus -9 squared. and that just works out to be 4 squared plus, and that will be minus 2 minus 9 is minus 2 plus 9, which is going to be 7. And then if we did that out, we would get 8.06 meters to 3 sig figs. Okay, last example here. It says we have two ships, A and B, have initial position vectors of 7i plus 2j kilometers and minus I plus 14j kilometers relative to harbour H. And the velocities of A, velocity of A is 2i minus 4j, velocity of B is 7i plus 6j. Find the position vectors of A and B at time t relative to H. Okay, right. I'm going to say this first one I'm doing is a position vector of A, so I'm going to say that's R subscript A. So initially, it has a position vector of 7, 2, and it moves with a velocity of 2i minus 4j, so that's t 2 minus 4. That's position vector of A. Same idea for B. It has, if you read the question, position vector of minus 1, 14, and its velocity is 7, 6. So that's what we've got. That's the first bit done. It says, hence or otherwise find the distance between the boats after 5 hours. So what we want to do for part 2 is let t equal to 5. So put t equal to 5 and then find out where A is. And then put t equal to 5 and find out where B is. So we're just putting the t equal to 5 into these two equations above. So for A, it's going to be 7, 2 plus, and then 5 times 2 minus 4. And if you do that on your calculator, if you need to, that's going to be 17, and then that's going to be minus 18. Yep, 17 minus 18. And for B, it's going to be minus 1, 14. Plus 5 times 7, 6. And then if you do that out, that's going to be minus 1. And then that's 35. That's going to be 34. And then it's going to be 14 plus 30. That's going to be 44. So that's the position vector of those two things there. Okay, the distance between them then, I'll just do it slightly differently than I did in the last question. The distance between them is just do 17 minus 18. 17 minus 18 minus the 34, 44. So this is the distance between them, or I should say the displacement between them is, and that will work out to be minus 17 minus 62. And then you work out your distance, square root of minus 17 squared plus minus 62 squared. Very quickly on my calculator, let me just check all this done, but I just need to check this every time because I've made so many mistakes. And that worked out to be 64.3 kilometers, and that's either the 3 sig figs or 1 dp, whatever you prefer. They're the same in this instance, and that's at 64.3 kilometers. Okay, right. Last bit says, show that the boats do not collide. Okay, now you do these questions the same. It could have said, show that the boats collide and find the time at which they collide. Your starting point is the same. What we're going to do is put my position vector of A equal to my position vector of B. And we'll just try and find a value of t. Right, so just say, we're going to part C, we're saying put R of A equal to R of B. And then we'll just do that. Let me write this down quickly and then I'll zoom in on it. So 7, 2 plus t times 2 minus 4 is equal to minus 1, 14 plus t 7, 6. And then we'll just go with that. Now, what we're going to do is we're going to equate the i's and see what we get for t. And then we're going to equate the j's and see what we get for t. And if they had been the same, that means they would have collided. And if they had not been the same, then they'll not collide. So we have to find out if that's the case. So 7 plus 2t, looking at the t's on the left, the i's at the left-hand side, then the i's at the right-hand side. That's what you'll have. Tidy this up. 7 plus 1 is 8, and then 8 is equal to 5t. When you bring all the t's to one side, wee bit of working out, t equals 1.6. Now we'll do the j's. So looking at the j's on the left-hand side, so that's what I'm talking about, sorry. My i's, there's all my i's there. That's where that first equation comes from. And my j's, and remember the t is included in that as well. That's where this is going to come from. So 2 minus 4t is equal to 14 plus 6t. So that's where that has come from. And that'll be minus 12 then is equal to 10t. And my t works out to be my, sorry, is that right? Yeah, I think it is right. Yep, minus 12 is equal to 10t, which means t works out to be minus 1.2. I'll just say then, inconsistent, therefore they never meet. So do not collide. And that is it. Okay, so a tricky enough wee question there. Just highlight there where I got my second one there. But the big key thing is your i's and j's are not the same. Or sorry, your t values are not the same when you equated your i's and then equated your j's. So they will never meet.